Okay. 5.3. Solving systems of linear equations, solving systems of linear equations by elimination. And elimination is going to be your go-to method for solving these systems. We have looked at solving systems so far two different ways. We have graphed them and got the intersection of the lines. We have solved by substitution and got the ordered pair, which tells me where those lines cross. Elimination is going to give us an ordered pair as well of where these lines cross graphically. Best way to kind of do these, I'm not going to give you a long, drawn-out process with it. We are just going to work the problems and kind of go from there. So here's how elimination works. And like I said, it will be your go-to method. Here's an example. 3x plus 2y is equal to 4. 3x minus 2y is equal to negative 4. And with solving by elimination, if it just said solve this system of equations, you could certainly graph this. Not very easy to do to solve for y. Get out some graph paper, get your intersection. You could solve for one of these variables, for x or for y. You'll be dealing with fractions using substitution. Not going to be fun. Elimination, here's what we can do. It takes in this idea of adding these systems together because we want them to be the same. I'm going to add them up. The first thing I do is I look. Are my x's, my y's, and my constants lined up? They are. The second thing I'm going to look for is going to be coefficients. I want coefficients that are the same. 3x and 3x are the same. 2y and 2y are the same. The coefficients, the numbers in front of the variables, are the same. Well, what else I'm going to look for is these signs being opposite. Because I'm going to take advantage of the fact that I can add these two equations together, and if I add anything, let's say this, negative 5 plus 5, 0. 2x minus 2x, 0. Whenever I have the same things with opposite signs and I add them together, it goes away, it becomes 0. It eliminates. That's what we want to do here. Once these are lined up, I'm now going to start focusing on how can I eliminate one of these variables so I can solve for the other. And I'm going to do this by adding these equations together, because if I add these two together, this is going to go away because a positive 2y minus 2y is 0. Add these up. 3x plus 3x, 6x. 2y minus 2y, 0. The y's eliminate. That's what we want, because 4 minus 4 is now 0, and I can solve for x. Divide both sides by 6. X would equal 0. Look at how easy it was to get one of my coordinates of my solution. How do I get my y? The same way we did with substitution. I'm going to take this x and plug it into either one of these equations to solve for y. I'm always going to be given a choice. If I'm solving for y, equation 1 and equation 2, I'm going to choose equation 1 every time because this y is positive. It will be less mistakes, easier to solve. I take this 0 and I substitute it in right there for x, and I certainly can solve for y. 3 times 0 plus 2y is equal to 4. That goes away. 2y is equal to 4. I would divide both sides by 2. Y then is equal to 2. I have the ordered pair. Mr. DeLong, is this right? I don't know. Check it. Well, I just checked it here. 0 plus 4. 4 equals 4, it checks. Check it in your second one. 0, negative 2 times a positive 2, negative 4. Negative 4 does equal negative 4. It checks. They will be far and few between where they line up nicely like this. We're going to do 4 or 5 problems like this just to get the hang of it. But the majority of them are going to be what follows. Next example. Negative 10 x plus 3y is equal to 1. And I have negative 5x minus 6y is equal to 23. I have a system, and I am going to use elimination. And again, if I gave you this and just said solve, you're not going to want to graph this. This is not going to be easy to solve by substitution. None of these variables are easy to get by themselves. You're going to have fractions. Elimination is going to be your go-to. First thing you do, make sure everything's lined up. I have x's with x's, y's with y's, constant with constants. That means when I add them down, I'm going to have like terms. They're all going to be organized. Second thing I look at, do I have coefficients that are the same? No, that's a negative 10, that's a negative 5. That's a 3, that's a negative 6. But I do have some signs that are opposite. And wouldn't it be nice if this was a negative 6? I'm sorry, not a negative 6, a positive 6. Because 6y minus 6y would be 0. It also would be nice, wouldn't it, if maybe this was a positive 10. Here's what we can do. I can multiply this equation or this equation by any number I choose, and as long as I multiply each term by it, I don't change the value of it. I don't change the value of it. I'm just going to show you a little something right here before we move on. If I have 6 plus 8, and let's say 7 plus 4. 6 plus 8 is 14. 7 plus 4 is 11. My ratio of equation 1 to equation 2, I'd say, is 14 to 11. What happens if I multiply each of these terms by 2? Well, if I multiply by 2, that would be 12 plus 16. Shouldn't that equal 14 times 2, which is 28? And it does. If I multiply every term in the second, that would be 14 plus 8. That should be 22. What's 11 times 2? 22. And again, if I set this up as a little ratio, 28 22nds is still 14 11ths as far as my ratio goes. If I multiply every term of an equation by the same number, I don't change the value of it. It might get bigger or smaller if I multiply by a positive or a negative, but I can always divide back through by whatever I multiply by, dividing all of these by 2 and get with what I started with, not changing the value of it. In this one, since these signs are the opposite, I want to make this a positive 6. And if that needs to be positive 6, I need to multiply this whole equation by a positive 2. And I certainly could have multiplied the bottom by a negative 2 to make my x's go away, but I'm going to make it a little bit easier on myself because these signs are opposite. When I start multiplying by a negative, I certainly have to watch my signs. 2 times negative 10x, negative 20x. 2 times a 3y plus 6y, 2 times 1 is equal to 2. Watch this one right here. And I messed this up this morning in my other class. I took the 2 times something here. I don't even know what problem I did it on, but I multiplied it wrong. If you don't distribute this right, this isn't going to be correct when you go to solve for your variable. Sometimes we forget to multiply what's on the right of the equal sign, or we multiply it incorrectly. go through and double check. If I multiply everything by 2, I should be able to divide back 2 and get with what I started with. Half of 2 is 1, half of 6y is 3y, half of negative 10x, or 20x is negative 10x. I multiplied everything by 2. This stays the same. Negative 5x minus 6y is equal to 23. Now I can add down. Negative 20x subtract 5x. Negative 25x. 6y minus 6y eliminates. That's what I want. 2 plus 23, 25. I would divide by negative 25. X then would equal a negative 1. I take that x and plug it into either one of these equations. Doesn't matter which one, I'm going to go right here because it's closest. I know I'm going to have a negative times a negative and a negative 6y. You could certainly choose this one. I just want to say I'm going to do this one because it's closer. Negative 5x, x is now negative 1, minus 6y is equal to 23. Negative times a negative, positive. 5 minus 6y is equal to 23. I would then subtract 5. Negative 6y is equal to 23 minus 5, which is 18. I would divide both sides by negative 6. That means y is equal to negative 3. I have the ordered pair, negative 1, negative 3. And I can certainly check that. Negative 1, if x is here, would be a positive 10 minus, 3 times negative 3 would be minus 9. 10 minus 9 is 1. I can check this one. 5 plus 18 does give me 23. I'll box it in. Next example. And again, you certainly could have chose to multiply this bottom by a negative 2. That would have just got my x's to eliminate. You are still going to get a y of negative 3 when you do it that way. You are going to be left with choices of what to do. What I would get away from, though, is multiplying by any sort of fraction or decimal. Here's the next equations, next system. Negative 2x minus 5y is equal to 9. 3x plus 11y is equal to 4. Your x's and your y's are lined up. Your constants are lined up. Do I have any same coefficients? I do not. Do I have any signs that are opposite? I certainly do, right here and right here. Now I just need to think a little bit. It would be difficult to make this 2 become a 3, this negative 2 become a 3, or this 3x to become a negative 2x. You want to think of this kind of like a common denominator. If I wanted to get a common denominator between 1/2 and 1/3, if I wanted to get a common denominator between 1/2 and 1/3, I could always take 2 times 3 and know that my common denominator is 6. 3, 6, 2, 6. And then I could add those together. You could do the same thing right here, because wouldn't it be nice if this was a negative 6 and this was a positive 6? It's a little bit easier to work with than whether this was negative 55 and positive 55. I am going to need to multiply both equations by a number here, but they're both going to be positive. So I need to take my first equation. If I'm looking to make this negative 6, I could multiply the top equation by 3 and the bottom equation by 2. And I could have certainly multiplied the top by 11 and the bottom by 5 as well. I just chose 2 and 3 because they're smaller numbers. Rather than multiplying this top by 11, I get bigger numbers. It doesn't matter, though, how you choose to do it. I know I want to get my variable to eliminate. I'm going to work with it this way. 3 times negative 2x, negative 6x. 3 times negative 5y, negative 15y. 3 times 9, 27. And again, I didn't change the value of it. I just multiplied it by 3. Yeah, these numbers are bigger or smaller, but if I divide everything back by 3, I'm going to get with what I started with. If I do everything the same, if I do the same operation to every term in it, I'm not going to change the value. This would become positive 6x plus 22y is equal to 8. Boom, boom, boom. I now have coefficients that are the same with opposite sides, a nice opportunity to add down and get those x's to eliminate. Negative 15y plus 22y, 7y, 28 or 27 plus 8 gives me 35. I would divide both sides by 7. Y is then equal to 5. I take that 5, plug it into either equation to solve for x. I'm going to go right here because it's closer, and my y is positive. This x is positive. The coefficient in front of it is positive. This equation then becomes 3x plus 11y, but y is 5, is equal to 4. 3x plus 55 is equal to 4. I would subtract 55. 3x then is equal to 4 minus 55 gives me a negative 51. Divide both sides by 3. Negative 51 divided by 3, 17, and it's negative because a negative divided by a positive, and I have the ordered pair, negative 17, 5. And I could certainly plug that back in and check it. No matter how you choose to eliminate or get a variable to eliminate, whether you're multiplying by a fraction or a decimal, which some people tried to do, don't do it. Keep it simple. Right? I could take 2 and multiply it by 1.5 and get 3. But then I'm multiplying this by 1.5, this by 1.5, this by 1.5. I don't like it. I would rather multiply both equations by a whole number, work with some bigger numbers to make the math easier in the end. A couple more. (3x) minus 30 is equal to y. 7y minus 6 is equal to 3x. Before I even start doing this, I can see this might lend itself nicely to substitution. This is what y equals. I could take this whole quantity and plug it in for y and use substitution. I encourage you not to do that. The first thing I would encourage you to do, we can always go back to substitution if you're looking for the easier way, but I'm telling you, elimination is always going to be your easiest way. I first want to get this to line up, meaning I want this y to come over here, this 30 to come over here. Then I'd have my x, my y, and my constant. That means if I take this equation, if I add 30, that's 3x is equal to 30 plus y. And now if I subtract y, I have this. 3x minus y is equal to 30. Do you have to show these steps every time? I probably would, because what we tend to do is like, oh, Mr. DeLong said I just need to move these around. Well, yeah, you need to move them around, but remember, when I cross the equal sign, I got to use inverse operations. That would be a positive 30, that would be a negative y. Be careful there. Same thing here. This 3x would come over, this 6 would go over. If I bring that 3x over, it's a negative 3x. If I bring this 6 over, it's a positive 6. So I'd have my 7y there and positive 6. Now, by just a little simple rearranging, I've got something that'll eliminate. Still going to be way easier than substitution. Add these down. Coefficients that are the same with opposite signs. Add them up. X will eliminate. Negative y plus 7y, 6y, 30 plus 6, 36. Divide by 6. Y is equal to 6. I think it's way easier doing it this way. A little bit of rearranging allowed me to eliminate. Take that 6, plug it in for y. I don't care which one you use. This one, y is already by itself. I could take this y, put it in right there for x. 7 times 6 minus 6 is going to equal 3x. 42 minus 6 is equal to 3x. 42 minus 6 is 36, is equal to 3x. I would divide by 3. X is equal to 12. You can check them. 36 minus 30 would indeed give me 6. 42 minus 6, we did that. Is that equal to 3 times 12? Yeah, it certainly is. 36. 42 minus 6 is 36. It checks, and I box it in. Last example. 11x minus 20y is equal to 28. 3x plus 4y is equal to 36. No coefficients that are the same. All my x's and y's are lined up. I'm looking for some opposite signs. Negative, positive, meaning if I add down, wouldn't it be nice if that 4 was a 20? What would make that 4 a 20? If I multiplied everything by 5. I could also work with this. If this was a 33, right? I would have to multiply this by 3, this by 11. One of them would have to be negative, so they'd eliminate. A little too labor intensive. If I've got these opposite signs, this is what I'm probably going to work with the majority of the time. Just depends on how it comes out. But you are free to choose. I think it's easier if I just take this and multiply by 5. This equation would stay the same. 5 times 3x, 15x. 5 times 4y plus 20y. 5 times 36, 180. Add down. 11 and 15, 26x. Y's eliminate, that's what we want, is equal to 208. Divide by 26. If you take your calculator out, you will get x is equal to 8. I will take that 8, plug it into either equation, and solve for the other variable. 3 times 8 plus 4y is equal to 36. 24 plus 4y is equal to 36. I would subtract 24. That goes away. 4y is equal to 36 minus 24 is equal to 12. I would divide by 4. Y then is equal to 3. I have the ordered pair 8, 3. I'll check it. 88 minus 60 is 28. I know this one's correct. 24 plus 12 is 36. It checks, and I'm going to box it in. That is elimination in a nutshell. There are certain other little things that are going to come up as we go through, but that is the nuts and bolts of it. I've also added some Khan Academy videos. I have also added in there the bookwork lesson, which is this sort of stuff written out in kind of a step-by-step fashion. These are more of example problems, so we got some stuff to work with. This is what we're going to be doing the majority of the week. Good luck. Let me know if you get questions.